LeetCode 252. Meeting rooms seems like a basic scheduling task, but under the surface, it's a real-world challenge. Think calendar apps, job schedulers, or reservation systems. You're constantly asking, can all these events happen without crashing into each other? Our job is to find overlaps, fast. With thousands of intervals, brute force gets ugly. So, can we dodge the drag and find a leaner route? Let's kick off with the rubber ducky baseline. Try everything and spot what breaks. We'll check every possible pair of meetings to see if any two overlap. Let's code it out and see how bad it gets. First, we grab the number of meetings so we know how many pairs we're dealing with. We drop into a nested loop. For each meeting, we compare it with all meetings that come after. This way, we avoid checking the same pair twice. Our goal here is to catch any overlap. If two intervals intersect, there's no way one person can attend both. The moment we find overlapping intervals, we return false, because that's a conflict right there. But if we check every pair and find no clashes, we return true. All meetings are attendable. To support our check, we build a helper that determines if two intervals collide. We just test whether one starts before the other ends, and vice versa. This brute force method runs in big O of n squared. For 10,000 meetings, that's up to 100 million checks. It's space efficient, just big O of 1, but not built for scale. No integer overflow issues here unless you go beyond 10-digit timestamps. So how do we cut the clutter? What if we sort the meetings first? That way, we can just check neighbors instead of every combo. Let's see what sorting buys us. We make a fresh copy of the intervals so we can sort freely without messing with the original input. Always a good habit in shared code bases. With our copy ready, we sort the intervals by start time. That way, any overlapping meetings will sit right next to each other. Now we walk through the sorted list, checking each consecutive pair. We're watching for a new meeting starting before the last one ends. Here's the key test. If the current meeting begins before the previous one ends, we've got overlap. We return false right away. If we make it to the end without tripping that check, it means all meetings are clear, so we return true. This sorted version runs in big O of n log n, about 130,000 steps for 10,000 meetings, way better than 100 million. But we do pay ON in space for the copied array, which could matter on memory-limited platforms. But can we do better? Sorting is fast, but scanning only adjacent intervals leaves power on the table. Let's simulate time itself and sweep through the schedule like a timeline. To simulate time, we build a sorted timeline of events. A TreeMap fits perfectly. It keeps times ordered and lets us walk through them in sequence. We go through each meeting, marking the start time with a +1 and the end time with a -1, tracking how many meetings start and end at each point. Once we've set up the timeline, we're ready to count active meetings. We'll use a counter to track how many are happening at any moment. Walking through the timeline in order, we update the count based on meetings starting and ending. It's like a running tally of what's live. If at any point we see more than one meeting active, we return false. That's an overlap, plain and simple. But if we make it through the whole timeline without breaking that rule, then it's safe. No conflicts found. This sweep line runs in big O of n log n, similar to sorting, with the TreeMap handling ordered events. Each insert takes log n time, and space is ON. In interviews, this technique shows mastery of interval logic. It's clean, scalable, and production ready. We started with brute force, simple but painfully slow. Then we trimmed the fat by sorting and just checking neighbors. A big win in speed. Finally, we got surgical with the sweep line, tracking events across time itself. That gave us real insight into overlaps, exactly what production systems need for bookings, events, or logs. This isn't just theory. It's the kind of thinking that makes you stand out in interviews. So ask yourself, where else can this sweep line idea level up your code? Keep pushing, because the next breakthrough might just be one duck away.